Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look at some AP Calculus review concepts that can help you and your students be successful on the upcoming AP Calculus exam. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI Technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm really excited to introduce our panelists for tonight. We have Vicki Carter, Steve Kokoska, and Tom Dick. Vicki has been teaching high school math for 40 years and currently serves as the math department chairperson at West Florence High School. She is co-chair of the AP Calculus Development Committee and serves as a question leader at the AP Calculus reading. Vicki has served on TI-Nspire authoring teams and has presented at many international, national, and regional conferences in the areas of technology, calculus, and statistics. Vicki, thanks so much for being with us.
Thank you. I'm so glad to be here tonight to share this information with everyone.
And Steve received his undergraduate degree from Boston College and his master's and PhD from the University of New Hampshire. Steve just completed his term as chief reader for the AP Calculus reading and member of the development committee. Steve has written several graphing calculator manuals to accompany statistics and pre-calculus texts, and is co-author of the CRC text, standard probability, and statistics tables and formulae. He has given numerous presentations on graphing calculators and AP Calculus at College Board workshops, the T-Cubed International Conference, AP National Conference, NCTM, and to area high school students and teachers. The second edition of his introductory statistics text was published in January 2015, and he's now working on an AP Calculus text. Steve, thanks so much for being with us tonight.
Thank you very much, Michael. I'm delighted to be part of this webinar series.
And last but not least, Tom is a senior mathematics advisor for Texas Instruments and is also professor and former chair of the mathematics department of Oregon State University. He has served on the editorial panels for the Journal for Research in Mathematics Education and the Mathematics Teacher Educator. He remains active in the College Board's Advanced Placement Calculus program and has previously served as chair of the AP Calculus Test Development Committee. Tom, thanks for being with us.
Thank you, Michael, and it's a delight to be here with everybody.
We're expecting a very large crowd, so please send any questions that you have for Tom, Vicki, or Steve using the Q&A window on the right side of your screen. As a reminder, this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues tonight, but in the event that you do, try selecting Communicate from the top of the WebEx menu and choose Audio Broadcast. You can toggle that on and off. And if that doesn't fix your audio issue, find the participant window. And the bottom left of the participant window, there's a little phone icon. If you click on that, you'll get instructions to call in using your phone, and that should solve any audio issues that you have tonight. At this point, Vicki is going to discuss our agenda.
All right, tonight the first thing we're going to do is talk about the format of the new exam. There have been some changes, so we will outline those for you. We will also talk about, almost throughout the presentation, the uses of the calculator on the AP exam, what we expect you to be able to do or your students to be able to do on the exam, and we're going to go through a few examples that highlight that. As far as communicating well on the exam, this will sort of happen throughout the webinar. We will point out some times that students need to be very careful about how they communicate, write responses, write equations on the exam in order to receive full credit. We will also, probably throughout the webinar, talk about do's and don'ts with technology as they come up, but we will have a specific list that we will discuss with you. We're then going to go through an example of a calculator active problem or two, and then we will have the actual scoring of one sample free response question that I think was on last year's exam. Then we will cover some online resources and some other various odds and ends, such as the webinar giveaway at the end of the webinar.
Thanks, Vicki. And Tom is going to discuss our expected outcomes.
Thank you, Michael. So what we're hoping you'll get out of the webinar tonight is some familiarity with the format and the instructions for the AP exam, so you can pass those on to your students and make sure they're best prepared to do their best performance on that exam. Communication is something that's highlighted, I think, in the, well, it's always been important on the AP exam, and with the new framework, it's especially important, and so we'll be highlighting that as we go. We do want to put a special spotlight on the use of technology on the exam. The AP exam does have calculator active questions on it, and there are some do's and don'ts that we want to make sure people are aware of and can help their students use the best strategies, most intelligent use of the calculator on the exam. And then Steve, as a former chief reader, is especially well equipped to share with us some insights about how free response questions are scored at the AP reading. And I think that's always something that's helpful for teachers to know.
Thanks so much, Tom. Vicki, it's all yours.
Okay, we'll go to the next slide first, if you can, please.
Yep, sure thing.
Okay. All right, so the first thing we wanted to share with you is to make sure you understood the format of the exam this year. There are some changes with the multiple choice. There will now be 4 choices instead of 5 on the multiple choice questions, and there has been a slight shift in the number of questions and the timing on the 2 parts of the multiple choice part of the exam. So part A of the multiple choice, which is the first part that the students will complete, will now be 30 minutes, and that is where the calculator is not permitted, and for those 30 questions it will be 60 minutes. The second part, where the calculator is required for the multiple choice, there will be 15 questions, and that will be 45 minutes. You will not see a reduction in the number of calculator active questions in that section, and if you're familiar with the exam, you know that not all of the calculator, or not all of the questions in the calculator section actually require a calculator. So there will be the same number that you've seen in the past in that section. There have been no changes to the free response part of the exam. We will still have two calculator questions, which the students will complete for 30 minutes. And at the end of that 30 minutes, the students will be asked to put away their calculators. They will continue to have access to those 2 questions, but no access to their calculator, and then they will also be shown for the first time 4 additional questions that will give them another 60 minutes to complete. And so the exam is, that part of the exam is 1 hour and 30 minutes with the free response part. All right, as far as calculator use in the exam, there's really no change from the past of what we expected students to be able to do with their calculator. First and foremost is that they need to be able to plot a function that we give them with a given window. It might be a window that's not the standard window, but they need to plot these windows, these graphs on the windows that we show them on the exam in order to actually see what they're really working with. And so they may want to change the X-min and the X-max and the Y-min and the Y-max of that window. When they're on that graphing screen, they should be able to find zeros of functions. They may also have to find points of intersection when they're on the graphing screen. There are other ways of doing that, but it works really well from the graphing screen. They also need to know how to numerically calculate the derivative of a function at a point. and how to approximate numerically the value of a definite integral. So we're going to go through a few examples that highlight the tools that the students need to have in using their calculator. All right, so now you can pass it to me.
You got it, Vicki, so go ahead and share your desktop.
All right, Tom, do we want to go to the 84 first or the Nspire first?
Either one's fine. Why don't we go ahead and go to the 84?
Okay, so here we go.
Okay, so did want to go through a few kinds of do's and don'ts regarding the calculator on the exam. So one of the things, regardless of the calculator, that you want to make sure that the calculator is in radian mode for anything involving trigonometric functions. So that is usually on pretty readily apparent at the top of the screen. That's going to be true for both the TI-84 and the TI-Nspire. So you can see at the top of Vicki's screen up there, it has radian mode, and that's the mode that she does want to be in. There's really, I can't think of any instances where there were cases where students needed to be in degree mode for anything whatsoever on the AP Calculus exam. Steve or Vicki can correct me if their memory serves them differently, but I think radian mode is just the given for using trigonometric functions. That said, I do want to reassure people that at the AP readings, the readers of the exams are vigilant for the cases where students are mistakenly in degree mode. And so while there is a penalty for that, they try to make sure that students are not overly penalized over and over again for being in degree mode.
Yes, Tom, we actually say we're trying to award, points for good calculus, so we don't want to penalize them too much for being in degree mode.
So I think my list of do's and don'ts, there's probably a few more don'ts than do's. So the do is on the radian mode. On don'ts, one of the things I'd emphasize is if you're doing an arithmetic calculation, there's really no need to simplify that once you have it down as a numerical expression. The same is true for an algebraic expression, that there's no, once you've got it resolved to an algebraic or arithmetic result, you don't have to combine numbers, okay? And so students that go ahead and do that are really kind of subjecting themselves to making mistakes that they could get dock points for. And so it's not in their best interest to be overly concerned with trying to simplify answers, okay? Given that it's a timed exam, their effort should be on getting an answer and then moving on. That said, with a numerical result, if a number is presented in a decimal form, it is expected to be, unless otherwise specified, accurate to 3 decimal places. And one of the mistakes that can happen is premature rounding. So in the middle of a problem, students shouldn't really round results until they get to that final answer. And we'll illustrate that with some examples here. So let me give you an example of, I'm going to pose this as a task to Vicki to try on the 84 here, but this is something that could very well appear on as a multiple choice question. So Vicki, the task I have for you is I'm interested in looking at the function sine of e to the x. And so if you want to go ahead and enter that in. And my interest in this is that that's the derivative of the function I'm actually wondering about. So the derivative of the function I'm wondering about is sine of e to the x. And I'm wondering what the original function, how many relative minima it has between 0, x equals 0, and x equals 4. Okay. Now this is a problem where, given that as the derivative, if you try to anti-differentiate that, either by hand or with a computer algebra system, you'd be kind of stuck. However, the question I asked had to do with relative minima, and that's something we can answer graphically by looking at the graph of the derivative. So Vicky's gone ahead and graphed the function that I gave her. And this window that we've got here, we might want to adjust that. She went ahead and set her window from 0 to 4, x min, x max. We might want to go ahead and change the y min and y max to maybe -2 to 2 to use more of the vertical space on the screen. There we go. Okay. Now, a question like this, what would we be looking for? So remember that this is the graph of the derivative. And so we're looking for the number of relative minima of the original function. And so if we think through that, okay, at a relative minima, that's going to be where the first derivative changes sign from negative to positive. And so what we really want to be looking for on this graph are the places where the graph changes from negative to positive, and count how many times that happens between 0 and 4. So let's see, Vicky's pointing at the first one, it looks like, that we've seen. And then, well, there's quite a few, isn't there? There's the second one. And if we keep going, 3, 4, 5, 6, 7, and 8. So there's 8 of them there. So. Now notice that if you misinterpreted this and thought about the graph that we're looking at as being the one we should be counting relative minimums are, you might overcount here. Looks like we might be seeing more than 8 here. And I just want to point out that questions like this are actually pretty rich, where you're given a form for the derivative of a function, and it's not one that you can really do much with analytically. If we switch representations to the graphical representations, there's lots of calculus know-how that we can use and answer this. So, for example, one could ask how many inflection points the original function has. And so there's a lot of questions you can ask in this kind of graphical way. By the way, there are some questions on the AP exam where the graph might be presented to you. But here is the one where the way I posed it was I was given a form that if you tried to anti-differentiate it by hand or with a computer algebra system, this would be one you really couldn't do much with. Okay. I'm fond of saying it's not one you could touch with a 10-foot pencil. So, okay. All right. So let's try another example. And in this one, maybe we could switch over to the Nspire just to kind of get some experience with both platforms here. First thing I'm checking on Vicky's thing is on her screen up here. I noticed up there in the top it has RAD. That's good. She's in radian mode. And I'm going to ask her to go ahead and get a graphing screen up. Great. And I'm going to give her...
Hang on just a minute. So the students need to make sure that they have radian mode showing both on their graphing screen and on their calculation screen.
Yes, and those can be set independently of each other, and sometimes students don't catch that. So here we see radians is also the setting for a graphing screen, which is really good. Okay, so a kind of a typical problem that students might encounter on free response, not every year, but most years, would be something involving maybe a couple of curves and calculating perhaps the area of a region bounded by those curves, or taking a region, rotating it around an axis, finding the volume, things like that. So I'm going to give Vicki a couple of curves here to work with. For her first curve, I'm going to give her the function f of x is 4 times the cosine of the square root
Oh, this looks like fun.
of x. Okay. I won't go too crazy, Vicki.
All right.
All right.
Are we going to have two equations, two functions?
Yeah, so you can go ahead and graph that one.
Okay.
And then for the second one, I'd like to look at just x cubed over 4.
Okay.
And there we go. Okay. So a question that, there's a variety of questions that could be asked. We've got a region here that's bounded by those two curves, and the y-axis, for example, we have kind of something that looks like a almost kind of a circular sector, though it's clearly not, that cubic and the cosine curve in there. So one of the questions might be to find the area of that region. Okay, so the region bounded by the y-axis and those two curves. So it looks like we would need to find an intersection point between those two curves. And this is one you definitely don't want to tackle by hand. And this is one of those functionalities that the calculator is quite handy at. We should be able to find that intersection point. I think I'm going to have Vicki actually go over to go ahead and introduce a calculator page to do this.
All right, there we go.
And notice she's already entered these things as F1 and F2. If she was working on the 84, it might be a Y1 and Y2, and these are things that she can now refer to. So I'm going to have her use one of the calculation functionalities, and that will be if we go to the menu and pull up, let's see, how about, yeah, algebra.
Are we going to solve?
Yeah, solve. Yeah, I'm sorry. I should have just said let's do a
Okay.
solve. And she could just put in F1 of x equal to F2 of x. And we could, comma, ask it to solve for x. There we go. Okay. All right. Now, Vicki, notice that this is, we talked about 3. This one is actually given to 5 decimal places, but it's actually given to much more than that. If Vicki was to type in A and S for the last answer.
Or another possibility is to just go up and highlight that response and press enter, and it would also show you more digits.
Okay, all right. And that, we might as well take advantage of all the accuracy that we have here. So I'm going to have Vicki actually store this as B. So she can do B colon equals or define B equals either way. And on the 84, there's a store command one could use. And then she could copy that value down. And that may also copy the X, but let's see. Yeah, you may want to just sweep over it. And
well, at the moment, it's not working. There we go. I got it.
Oh, there you go. There we go.
Okay.
Oh, there we go. And if we enter that, now that's a value that's stored in B. And in fact, students could write right on their exam that they find that value. They can write B equals this, and then just refer to B from there on out if they're using B for several times. So, for example, in an area volume problem, we might need that value of B in the area task, in a volume of a solid revolution task, for a variety of things. But once we've stated what we're calling B, we can just refer to it as B. So I'm going to have Vicki actually calculate the area now by pulling up, if we go to the menu and pull down calculus.
Oh, well, I just went to the template screen.
That works too, so either way works. She could pull up a definite integral template. And let's see, I think our lower limit would be 0. We can just type in the B here. And here's where we might want to go back and look at the graph. Let's see, okay, it looks like between 0 and that intersection point, looks like the blue curve's above the red curve, so we'll do F1 of X minus F2 of X. And then we'll be integrating with respect to X. And there we go. There we've got our calculated value. Okay. If we'd been asked for the, let's say the slope of the tangent line to F1, to the graph of the 4 cosine square root of X at that intersection point, we would need the value of the derivative there. Well, again, we have the X values, that value stored in B, and this is something we don't need to, for on the calculator active part of the exam, we don't need to do that derivative by hand. Notice that we did need to, if we were asked for the slope of the tangent line, we do need to know that that derivative is going to give us that value. And so Vicki's making use of this kind of little, forget what that box is called. Let's fill in parts of the template here. And there's the slope of the tangent line. And this is where I think, you know, looking at the graph, it's a good thing to have your students think about is, you know, look at the graph and just looking visually, does that make sense? Does that value, for example, if we had mistyped something in, does that slope value look reasonable? Okay. And in this case, we can see that it looks like there must be a negative slope there. Okay.
Yes. And Tom, can I also mention there's another way from the graphing screen to find that point of intersection and store it that might be convenient for the students to know?
Please do, yeah. Well, I was hoping to do another way.
Oh, okay. So under menu, you've actually got 2 possibilities. You have Analyze Graph, and so I'll go down and look at Analyze Graph. And here we have 0 and the 4th one, Intersection. And so we could use this tool. It's also under Geometry, Points and Lines, Intersection, and so that's a different way that you could approach it. But let's just do it with the Analyze Graph. So I'll go down to Intersection, select Enter, and it asks me for a lower bound, which means I need a value that is smaller than what the x-coordinate of the point of intersection is. So I will click here, and then I need an upper bound larger. Now, one of the disadvantages of this is that we see only 2 decimal places for our the x-coordinate of the intersection point. We can display more digits, but even though the calculator is just displaying 2 digits, it's still retaining many, many more digits, very similar to what we saw on the calculator screen. So if I hover over that and press the plus sign, I will see a display of more digits. But I can also click on that value so that it's highlighted, and I can go to the Variables button, and it says Store Variables. And this time I don't want to call it B because we've already used it as B, so let's call it C. We'll get real original here. And when I press Enter, I want you to notice that the x-coordinate gets bold. That means the calculator has stored that value. And if I now go to the calculator screen that I have, and just type in a C and press enter. Let's compare what we have here with what we found when we did the intersection through the calculator, through the calculator application, and you will see something very similar. And again, if I go highlight it and press enter, you will see those digits, and if you compare it to the one we have above, we don't have quite as many digits, but it's very accurate. All right, Tom, I didn't want to steal your thunder there, though.
No, that's perfect. I was actually hoping you would jump in and point out at least one of the multiple ways that one could approach this. Okay, so that's, like I said, I think we've actually touched on most of the different calculator functionalities, including one is actually graphing as a strategy to look at functions and interpret them graphically. So at this point, I think it would be good to turn it over to Steve, and so he can take us through how an AP free response question is graded.
Yes, and while we're on this, one of the things that you do need to be careful about in a response to a question on the exam is not to use calculator syntax. We don't see that as much anymore because most of the calculators actually use templates. But if a student happen to be using like a TI-83, they just need to make sure they use correct calculus notation and not calculator syntax. All right, let's see.
All right, thank you, Vicki. Can you send it over my way?
I think I did. No, I didn't. Hang on.
Okay.
I had to answer the question, but I wanted to send it to you. I forgot about that.
All right, how's that? Can you see that?
Yes.
Yep,
okay, this is AB1, BC1 from last year's exam. I think this is an excellent problem to review with your students as you prepare for the exam this spring. This is a calculator active problem. I'm not going to be doing any calculator commands on screen, but there are some places in here where you will need your calculator. And I think this is a very familiar type of problem. So I think this is an excellent review problem. I hope to show you the standard, of course, kind of quickly, but also show you some of the common errors that students made last year and to show you some of the grading decisions that were made, again, to help you prepare your students for this year's exam. So this one is about water being pumped into a tank at a rate modeled by a function W. Water is removed from the tank at another rate modeled by a function R. We know all of this is happening between 0 and 8, and R has some special properties. And we also know that at time t equals 0, there are 50,000 liters of water in the tank. When I teach problem solving to my students, at least with word problems, I try to ask them to identify key phrases and key words in a problem before they even attack the questions. And I think some of the key words here are rate. We're given rate functions. That's important for the students on this exam to realize, to recognize. And the other important thing I think to remember here throughout this problem is there is an initial amount of water in the tank at time t equals 0. So A is asking us for an estimate of R prime of 2, use the appropriate values in the table to do that. And B, we need a left Riemann sum. And we'd like to know if that's an overestimate or an underestimate with some sort of a justification or reason. In part C, we want to use that answer in part B, that estimate, to find another estimate for the total amount of water in the tank at the end of the 8 hours. And D was sort of a unique question, which we hope the students would use the intermediate value theorem to solve. Is there a time when the two rates are the same? Kind of a cool question. So let's see. Here we go. Here's the standard. There were 2 points for part A, 1 point for finding that estimate, that minus 120. And I'll go through this in a little bit more detail in a minute here about what the student would have to show to get that point. And the second point is for the units. In this problem, the units were asked for. We had a good question earlier, I think, and that was, well, what if the problem doesn't ask for units? Does the student have to provide them? And the answer is, in general, no, they do not. What if they provide some crazy incorrect units? Would they be marked wrong? And past practice suggests that no, they would not be. But here we need the units for a point. In Part B, 1 point for the left Riemann sum, that might be a little misleading. In my mind, that first point is a conceptual point, and that is, does the student or can the student convey to us the form of the left Riemann sum? And by the way, there was an interesting part of this problem, I think. It's a subtle part of this problem, and that is that it's not, the student is not told to find the definite integral or estimate the definite integral from 0 to 8 of R of t dt. They have to know that. They have to read this problem and know that that's the definite integral they want to estimate. There were no points for that, but they had to know that. The second point in Part B is for the estimate, the actual numerical estimate. And the third point is for recognizing that, you know what, this is an overestimate because R is a decreasing function and I'm finding a left Riemann sum. T was worth 2 points, 1 point for the integral. You don't see that on the left-hand side of the standard sort of standing alone, but the student could on their exam paper just write the definite integral, 0 to 8 w of t dt, and they would get 1 point if it were just sitting on the paper, disconnected with nothing else there. But on the standard, that is written as part of an estimate for the total amount of water. And then the second point in Part C is finally coming up with that estimate. And here's a part of the problem where the student would absolutely have to use their calculator to find that definite integral of 0 to 8 of w of t dt. And then in Part D, this sort of interesting problem here that relies upon the intermediate value theorem. I guess we had hoped that students would consider a new function, w of t minus r of t, and take a look at a couple of values of that, recognize that it is continuous, and apply the intermediate value theorem. I understand from the grading that unfortunately many students did not try or attempt to solve the problem this way, but rather looked at two separate functions, w and r, and tried to show where they crossed. All right, I thought you might like to know a little bit here about the question team. Virg Cornelius was the question team leader here. She gave the briefing, and Mark Kanowski and Christy Meyer were part of the question team also. Student performance in general on this problem. This was a contextual problem. There's a lot to read here, and it was calculator active. In general, these problems are challenging for students. However, I would like to suggest that this problem was pretty accessible. It was pretty easy for students to enter this problem in any of the 4 parts. And again, it asked for what I would call traditional estimates. So I don't think this was really an off-the-wall sort of questions. I think students could get into this. In Part B, the third point, and Part D, the second point, this gets to one of the agenda item bullets. Students had a little trouble communicating and explaining, and in some cases they went on to say too much. What that means is students have given us the correct answer, but they just have to tell us more. So they continue to write more. In some cases, we ignore it. However, in other cases, if they go on to say something else and it's wrong, they could lose a point. And I can't give you a definitive rubric for that. It depends upon the year, it depends upon the problem, it depends upon the chief reader. So a little bit more detail on all of these parts. Part A, again, was worth 2 points. The first point was the estimate. Students had to return the correct estimate with some supporting work. In these types of problems, we look for 2 things. We look for a difference and a quotient. Students have these fancy calculators, and many of them try to use a regression equation, and we certainly don't want them doing that. If there's any evidence of them using a regression equation, they would not get the point here. And they have to pull R of 1 and R of 3 from the table, those values from the table. And they need not simplify, and I apologize, but let me explain that a little bit more. Students don't need to simplify an arithmetic expression. Algebraic expressions in general, yes, but if it's arithmetic, they do not. And the second point was a units point. It has to accompany a value. In other words, a student cannot say, gee, I have no idea how to do this problem, but here are the units. They still don't get the units point. And again, even though we asked for units in Part A, we're not looking for units in Part B, C, and D, and so they are ignored if the student added any units in there.
Steve, before you move to your next screen, can you go back to your previous screen?
Sure.
Okay, a question has come up about the regression equations. Basically what that is plugging in the values from the table and running like a regression. And I forgot what kind of regression the students ran on this. Was it a quadratic, I think, maybe? And so they were using the quadratic function that the calculator produced from that regression analysis, and that is not to be done on the AP exam. You should not have to do any kind of regression of any kind during the AP exam. So even though you might learn that in a class, or teachers might work with students on regression analysis in Algebra 1 and Algebra 2, please encourage your students to not use regression on the AP exam. Thanks, Steve.
You bet. So here are some specific examples of perhaps student work and how they would be scored on the right-hand side. So in the first one, the student has R of 3 minus R of 1 over 3 minus 1. You'll notice it does appear to be a difference. It does appear to be a quotient. However, this student hasn't pulled the values R of 1 and R of 3 from the table. So on the right-hand side, what I've listed as scoring is question mark, question mark. If this is all that appears on the paper, they get 0. But they may go on here and actually pull values from the table. So they're still eligible for those points, but as of right now, they've got 0. In the second one, 950 minus 1190 over 2, there is a difference. I see that in the numerator. There is indeed a quotient. Does not have to be simplified any further. That student earns 1 point, and we'll go on to see if they have the units anywhere. In the third example, 740 minus 1340 over 6 minus 0, we have a difference in a quotient. However, this student has used the incorrect values of R. An incorrect interval is the way that I would like to say that. So they do not get that first point. They are eligible for the second one if they report units. In the next one, we have a difference in a quotient. The difference this time is in the denominator. So that student gets the first point to the estimate. Next to the last one is an interesting one. There is a difference in a quotient, and remember, it does not have to be simplified, so that estimate is correct. And that's a little bit, not a different way, but another way to write the units, and that's okay. So that student would earn both points. And the last one on this page earns 0 points for the estimate. There's certainly no difference. There's certainly no quotient. The minus 80 is wrong. However, the units are correct, another way that we might see them. So that student would earn a 0 and a 1. In Part B, this was worth 3 points. We've seen a lot of problems in the past several years on the free response portion of the exam like this one. So for the first point, this sort of conceptual idea, we're looking for the products and the sums. I'm not going to go through this, go backwards here, but the first line on the standard earns this first point. That is that product, that sum of those 4 products. In this particular problem, we have what we would call a 7 out of 8 rule. There are 8 pieces to this sum and product. And in order for the student to earn this first conceptual point, 7 out of those 8 pieces must be correct. The second point is the actual estimate. We need to see that 80-50 or numerical equivalent answer with some supporting work. That 80-50 can't just appear out of thin air. And again, I'm not going to go back, but the second line on that standard, that is the numerical value for 80-50, earns both points. In other words, if that's all that appeared on the student's paper, that earns not only the conceptual point because it demonstrates the left Riemann sum, it has all 8 pieces, and it earns the estimate point because, darn it, it's the arithmetic equivalent of 80-50, and it doesn't have to be simplified. It's a numerically correct answer. And then finally, the third point, we want to have the students tell us that this is an overestimate and we want some sort of a reason. There are 3 reasons that were pretty common and acceptable that are given on this slide, and they decided at the reading this year that this point may be earned with no work, no numerical answer up there in Part B, but as long as they answered this one correct, they recognize what's going on with a left Riemann sum and a decreasing function, they could indeed earn that third point here in Part B. So on this next slide, I've got some specific values, and I apologize, I am using some red in here. These are just some specific examples on how they would be scored. So the first line has 7 out of the 8 pieces correct. That 4 is incorrect. That red 4 is incorrect. They have 7 out of the 8 pieces right, so darn it, they get the first point. They cannot get the second point. They cannot get the correct numerical answer, but they are eligible for the third. In the second line, this is just a little bit different way to see that 7 out of 8 rule. This time the student has pulled all the correct R values, but has made a mistake on the width of that third interval. That's a 7 out of 8 rule, first point. Don't get the second, eligible for the third. In the next line down, this student has made 2 errors, an error in the third width and an error in the fourth value of R of 6. And therefore, they don't earn the first conceptual point. They cannot earn the second numerical answer, or estimate, excuse me, but they are eligible for the third. The fourth example down is an example of one line that earns the first 2 points. So that earns the conceptual point and the numerical estimate. They do not need to simplify that. They can leave it just like that and get full credit, eligible for the third point. And the next example down is worth only 1 point. This is sort of in a gray area, but it's sort of crossed the line, I guess. We don't have enough supporting work here. We'll give the student the estimate point, but we're just not quite sure, or the student hasn't conveyed enough information as to where those values came from. And down at the bottom, this is an example of a communication issue, I think. If the student for the third point of B, excuse me, says it's an overestimate because the slope of R is decreasing. I'm not quite sure what that means, but it's not right. It's not acceptable. One might interpret that to mean that R prime is decreasing. I'm not sure if that's true. I guess R double prime would be less than 0. If that's true, I guess R would be concave down. And that's inconclusive as to whether or not we have an overestimate, so we certainly don't accept that. Okay, in Part C, this was worth 2 points. The first point for the integral, and I should have highlighted that. It is the integral. We need to see those limits 0 and 8. We need to see W of t as the integrand. We should certainly encourage your students, remember, to use that name for that function W. And I put differential dt in there with a question mark. I'd like to suggest that this is part of notational fluency and communication. Make sure that your students do use the differential in there, because if they don't, the integral can be ambiguous, and I'll try to give you an example of that. The second point is for the estimate. It has to be correct or consistent with Part B. I think this is a very reasonable, compassionate thing that readers do when they grade these exams. We try to read with the student wherever possible, so that if the student made a mistake up there in Part B but had a numerical estimate, they could bring it down here into Part C, and we're going to read along with them and score them where possible. They do need some supporting work here to earn that second point. Again, that answer just can't appear out of nowhere. Here are a couple of examples. So if the student wrote down 0 to 8 W of t dt, that's the only thing that appears on the paper, that's worth 1 point. That is for the integral. All of the pieces are there. If the student writes down an indefinite integral of W t dt, that's all that's there. That does not earn the first point. It has to be an integral. The next line down, we might argue a little bit about this one, but this is how it was graded. If we see that line on the paper, that gets both points. I concur that the integral is a little, I agree that the integrand is a little ambiguous there, but because the answer is correct, we'll assume that the student placed the dt in the proper spot. That's worth 2 points. Now contrast that with the next example. If a student writes 0 to 8, W of T minus 80/50, we don't know where that DT lies. It's ambiguous, inconclusive. That, unfortunately, is worth 0 points. They don't get the integral point. They do not get the estimate point. And I understand that there were some rounding issues here in this problem. So without going into great detail, I think Vicki and Tom have already talked a little bit about storing intermediate values. So there were some rounding errors here. Part D was worth 2 points, kind of a neat problem. The first point was for considering, as written on the standard, W of T minus R of T, this new function. We kind of hoped that students would solve this problem, this part, that way. So we hoped that they would create a new function and declare that W of A and W of B, declare those values where that interval AB contains 3 to 6. We hope that they would look at that. The second point was the answer with an explanation. We certainly wanted the answer yes. And it would be really nice if they showed us that this new function was 0, greater than 0 at one point and less than 0 at another. And because of the IVT, or because it was continuous, conclude that there must be some place where W is equal to R. Now, another way that they could do this is by taking a look at W and R separately and thinking about trying to determine whether or not those two functions would cross. I guess this to me seems like a tougher argument. It seems like the student would have to show a little bit more, work a little bit more to get full credit, but certainly possible. And finally, if the student just wrote down on their paper, pretty generous, W minus R, we would treat that as considering this new function, W minus R, and they'd get 1 point. If they were considering the two functions separately, and they considered those 4 values, W and R at 0 and 8, that would also be worth 1 point. So to conclude, a couple of common errors here, some sort of global common errors I think that we saw this year. We saw, of course, some wrong units, some students using the wrong interval. You know, this is a pretty common type of tabular function that we've asked over the years, estimating a derivative. And we sort of expect students to pick an interval closest to the value that we give them. Some students went on, unfortunately, and made a wrong simplification. Remember that on the pressure of this sort of an exam, high-stakes exam, they can leave a numerical expression unsimplified. In Part B, we had some students give us an incorrect sum, even though we were asking for a left Riemann sum. Students insisted on doing a midpoint or a right sum, a right Riemann sum. And again, unfortunately, there were some arithmetic errors. In deciding whether or not it was an over or an underestimate, students did not mention decreasing at all, and unfortunately, some mentioned concavity. In Part C, some students omitted that initial condition. If you remember back to the beginning of my part of this presentation, I took that as one of the key phrases or the key words in the statement of this problem. And there were, of course, some issues with the placement of that differential dt. And in Part B, many students did not declare or even work with a new function, or they didn't work with both W and R. So terrific. I think I got it all in there, Michael. I think I'm okay. I'm going to try to escape out of here, and I'll try my best to pass it back to you if I can.
Thanks so much, Steve. As we begin wrapping things up tonight, if you have any last-minute questions for Vicki, Steve, or Tom, please try to get those asked. I know they'll do their best to get those questions answered.
Mike, it looks like we've answered a lot of the questions in the Q&A throughout the session. I don't see any that we haven't addressed.
Great, thanks, Vicki. On that note, if there are any questions that come up, we are going to be doing a part 2 of this AP Calculus review in, I believe, 2 weeks from today. Same format. You can register on our website. And again, registration is free. The webinar is free. And so if you have any questions that you, again, didn't feel were answered tonight that you are really concerned about, please share any of those thoughts or questions in the post-webinar survey, and we'll do our best to get some of those questions answered in the part 2 of this webinar. We're really excited to share with teachers this summer that we're offering over 50 different workshops across the United States for some summer professional development. And earlier, Vicki mentioned during the agenda that tonight we're giving away for one lucky winner a T-Cube Summer Workshop conference registration for free. And tonight's lucky winner is Marsha Cole. So Marsha, we really hope to see you at a T-Cubed Summer Workshop. And for those of you that don't know, these summer workshops focus on different technologies, for instance, the TI-Nspire or the TI-D4. They can focus on different content areas such as, say, calculus. And they are, again, offered across the United States. So please visit our website to learn more about our T-Cubed Summer Workshops. Hopefully you might agree that there was some really great information that was shared tonight, and we'd love to hear, again, your thoughts and the conversation. So if you would like to continue the conversation that was already started tonight, like Vicki said, there was lots of great questions that were in the Q&A window. Please feel free to reach out to us on any of the major social media outlets. To receive a certificate of attendance, go ahead and click the link in the chat window. Also listed is a link for the documents that were shared by our presenters tonight. In case these links aren't working, don't worry, you'll automatically get a follow-up email, and in that follow-up email will be a link to the recording, a link to the certificate, as well as a link to the documents. If you're watching this on demand, please go ahead and copy that link into your favorite browser to receive your certificate. After the webinar, if you're in the need of any post-webinar follow-up, give us a call at 1-800-TI-CARES, or feel free to send us an email at ti-cares@ti.com. So thanks so much to Vicki, Tom, and Steve for everything you shared tonight. I thought, again, we had some really great conversations and things that reminded me of things I need to tell my students about whenever I go back into school tomorrow. So thanks so much for everything you shared tonight.
Thank you.
Thank you.
Thank you.
And thanks again, everyone, for joining us, and we hope to see you back online in 2 weeks. Have a great night.